Thanks for joining on such an early morning. Okay, so the title might have been misleading a bit. The idea is that we had to design something on Ledge for UEFI Secure Boot, mostly based on U-Boot because our current members boards mostly use U-Boot, and we're trying to present what we did, the discussions we had, the outcome of the discussions, and how the architectural design looks like. And this is not strictly a presentation. This is an open discussion. So we'll go through the slides. The slides are just an idea of what we did, and we can have a discussion on what do you think, if you have any requirements that we're not fulfilling at the moment, and figure out how the whole boot flow works for us. So, right, the first thing that we have to do is that UEFI supports, U-Boot supports EFI booting, but there's no payload authentication at all. So you can load the P binary, a P payload, you can jump to it, you can start loading it, you can boot the kernel directly as an EFI stub, but there's no verification at all on it. So the first thing that we had to do is figure out which library we want to use for the whole signature and crypto signing and verification. So this is where Akash's work comes in mostly.
Yes. I'm working on UEFI implementation on U-Boot in the last 1 year or so. And regarding UEFI Secure Boot, this is not my original code, but some guy from, I don't know, his name is Patrick, who I don't remember. Yeah, maybe. But I took over his work maybe 6 or 7 months ago, and I made a lot of change to improve the functionality and the quality of the code. And finally, I submit first version of my patch set last week. So you can use for your testing. But it's still under review. It's not merged yet. What I finished in this version is image verification using certificate or hash value. You know, normally we will use the certificate, but we can even verify image using unsigned image using the hash value. If you can calculate hash value in advance and put it in a signature database. So when we load that image, the calculated value and the value in a signature database can be matched. If they match, the loading can be allowed. And you know, in UEFI specification, there are 3 types of signature database: DB, DBX, DBT. DB is something like a whitelist of certificate. DBX is something like a blacklist of certificate. And DBT is another one. Currently, I supported DB and DBX. And I also have experimental code for DBT, but it's not included in my first version. But if you download the patch set from my Linux repository, it includes DBT support. But it's, as I said, it's experimental, and I never tested it. So it should work. Maybe.
So can you talk about the SSL? And we initially talked about using
This one?
Yeah.
Yeah. So since I took over his Patrick's patch, it took a long time before I submit the first version. There are a couple of reasons for delay. Actually, there is several missing components in U-Boot. One of which is a parser for certificate as well as signature. You know, the definition is the file format is clearly defined in Internet standard, but we need further as well as its compiler. So there are several options. But when I ask this question to the Ubuntu mailing list, most people prefer the kernel version, a Linux kernel version. So I imported most of the code from Linux kernel.
UEFI is using linking directly to OpenSSL, right? Yeah. That's one of the things we wanted to discuss. That the first idea we had is we don't need another SSL implementation. Just go again and link against what's there and what's working, and let's use that. But the first reply we get on the mailing list is do whatever the kernel does, because that's how we do it at Ubuntu.
There's two issues that sound right. One is it's not GPL,
yes,
some people object to, and also it's humongous, right?
Yeah. We had, okay, the GPL argument came up on the mailing list, and we had alternatives that were at least GPL compliant. But then you get into, we don't know what's the quality of the code in there, and we prefer the kernel one because it's, at least someone reviews that.
That makes sense.
Yeah.
Yeah, another issue is RSA decryption library. Ubuntu has another secure boot based on a fit image, FIT image, right? And in this format, we also used RSA decryption, but the library is optimized, specifically optimized for this use. So there is some missing feature. So I added some function too. Another issue here is we have to, DB and DBX is nothing but a UEFI variable. And these are very important variables, so they are protected by signature as well. So we need to implement variable authentication too. But currently, UEFI variable rely on a Ubuntu variable. So it's stored in a normal device. So the problem here is, UEFI variable can be non-volatile or volatile, but there is no difference for the Ubuntu variable. More importantly, as I said, the variable are stored in a normal device, so it's not secure, particularly not tamper resistance. So that is a big issue, and we need solution. Our solution is to use standalone services, right, on Opti.
Regarding the security and the tamper resistant, we had a very interesting discussion yesterday, but that storing it on a normal medium is secure, but it's the tamper resistance you want. That's why we're using the secure world.
Do you want me to speak on context on that?
Yes. Yes. It was actually a really good point. That's why.
Okay, so the whole question of whether or not it's secure to put the variables in. You can make the platform secure just by baking the keys directly into the U binary, and then the issue doesn't even show up. If you are storing the variables, it is possible to make the U-boot variables secure just with normal world code, in the sense of if you've got a monatomic incrementing counter, you can actually make sure that all the variables are signed when they're stored to disk, and the firmware can verify that they're actually correct. That gives you security, but it doesn't give you rollback protection. Or it gives you security, it gives you rollback protection, but it doesn't give tamper resistance, because you can still go and erase the variables, and then the platform probably has to brick itself or to go into some kind of recovery mode to resolve that. So moving all the variables, the discussion that Ilias and I had yesterday is, do we put all the variables into the secure world, or do we only put a portion of the data into the secure world? What's the right way to do this? My thoughts on this is, I think U-boot proper, just U-boot as a project, normal world only, should implement all of the UEFI variable authentication. And so to use that, image authentication, regardless of whether or not the storage is secure. Because that functionality, I mean, it just makes sense. And then the back end of that, of where you store, how you store those variables, there's still going to be some debate about that. I think the direction that Ledge is going with standalone MM to record those, to store to the secure world, well, basically send to secure world, and then on eMMC platforms, sign an RFPMB transaction and send it back to the normal world to secure to store onto the eMMC device. I think that architecture makes sense. But the default, like kind of the baseline, really needs to be with U-boot. Start with, make sure all the functionality works with variables as they exist right now. Yeah.
Right. So then the next one we had to deal with is that UEFI makes sure that the next payload you're going to boot is signed and verified. In order to have a trusted operating system and in order to be able to trust what you booted, the first things that come in mind is that you have to verify the DTB, you have to verify the kernel modules, and you have to at least verify the initRD you're booting, if you're booting via initRD. So we started getting into a discussion of how we want to verify that. We found there's a bunch of ways you can do that. One is very U-boot specific because there's fit images on U-boot, so you can say that I'm using fit to verify whatever is not applicable to the UEFI spec and move on. But then you're mixing and matching two different security on a single platform, and that's not what you want. The next thing that we thought doing is that UEFI specifies the DB, which let's call a key ring for now. So we thought of adding the keys on the DB database and write custom firmware code for U-boot that's going to verify non-PE executables. But that's not a real good idea as well, because you keep adding keys on something that's supposed to authenticate payloads. So you're allowing mix and match attacks from potential entries on the DB that, for example, if Microsoft signs on the DTBs, you can load a different DTB on your device. So what we ended up doing is that the U-boot has the ability to provide the DTB on the platform, right? And since you're via TFA, since you're verifying U-boot with UEFI, you magically have a verified DTB that you can use for your device. So you get the DTB authentication for free, and then you can move the kernel modules and the initRD verification to whatever the kernel has to offer, like IMA or DT-Verify or DMVerify or whatever is on the Linux kernel for verifying extra files. So on this matter, this is the decision we did in LED. So every board we support on the reference platform has an upstream DTB on U-boot, which we use directly and boot the Linux kernel with it. We don't load anything externally. We don't use anything externally. We use whatever the firmware offers. Right, and the next topic is the how do you securely store those variables? All right, so you have your variables on an ARM platform. You have the secure world running. And on the Socionext Syncquacer box, there's an implementation called standalone MM, which is supposed to take care of the variables on the secure world, which runs as an SPM payload. So the problem with the SPM functionality and the problem we've had to face on LED is that we don't only support ARMv8 platforms. So we have members with ARMv7 hardware where SPM is not working. So we couldn't reuse that code, and we had to come up with something else. The next problem, even on ARMv8s, we had the requirement of being able to run firmware TPM. Now, due to the nature of the security payload dispatcher and the secure partition manager, those two can't coexist. They both run on Securial 1. I think it's a code limitation, but yeah. You can comment on that.
Yeah. So, quick question about the ARM v7 platforms. Are we talking about EL3 being ARC64 and the lower exception levels being ARC32, or the entire secure world being ARC32 over here?
We haven't defined that yet, to be honest.
Okay, so could you elaborate on what was the different bits that you had to do? Because it's just an implementation choice at the moment. Standalone MM today just ARC64, but it could easily be extended.
We haven't actually launched standalone MM on Opti yet,
right.
So we don't know if we have to do anything for the 32-bit.
Right, right.
So this is one of the topics we don't know what's going to be there, but this is we have it on ours.
Hopefully, it should be an implementation thing rather than
that's what
in
we
the
hope.
Architecture. Yeah. That prevents that from happening.
Yeah. This is an actual question, but we have it, but we haven't been able to launch standalone MM yet. So this is to be answered within the next week. All right. So what we figured out is that standalone MM is a P binary provided by EDK2. The problem with standalone MM and the UEFI spec in general is that the variables it defines is complex enough. So you don't want to go and rewrite all these in a TA just to run on OptE, since you already have an implementation that's working. So what we tried to do was launch standalone MM in OptE, and the only thing you have to change on that matter is that standalone MM memory maps an OR flash, which lies on the secure world and uses this for the storage. So the devices we're dealing with don't necessarily have an OR flash in the secure world. So we're looking at an RPMB device. So the only thing we actually have to change on standalone MM, when we manage to boot it up on the secure world, is replace all the API and the storage medium it uses internally to memory map the flash and write to the flash, and make it use OptE APIs. That will give us the possibility to use an RPMB with minimal effort on our side, because the overall functionality of reading and writing on an RPMB from Linux and U-boot is already there. So this is U2. You can actually, since it is an open discussion, you can talk about what didn't work at the beginning and then what we're trying to do to work.
So, okay, firstly, I want to talk about my prototype that didn't work, the problem I found along the way. Firstly, my prototype was trying to make the existing MM protocol, the one that talks from the non-secure world to the standalone MM in the secure world nicely. And the second one, I want to make a reuse of the OptE functionality, the user TA code base, and use that and extend it into the SPM sandbox so that we can launch the SDMM in a short time in the OptE. So it might sound nice that we can reuse most of the thing, but it doesn't. So firstly, if you start to talk the OptE with the MM protocol, the MM protocol expects it to be a fast call. So everything should be completed within that call. For example, if you want to write a flash memory, if you want to write some variable over there. But the thing is, normally user TA doesn't touch its own device directly. So as Elias said, it depends on the non-secure world based provided RPMB device. So it has to jump back and forth between non-secure world and the secure world. So this would happen. Non-secure world would call the MM protocol, and then in the middle of the process, the SDMM would call the OptE message back to the non-secure world asking for accessing the device. But since it is entrance with the MM protocol, the handler doesn't understand what OptE is, so it just ignores. So it cannot be handled. And the next thing, because I extend the user TA, so the user TA is kind of a threading. It can be sleep. So it can be sleep in the middle anywhere, and we don't know. And because it's a thread, it can be suspended and maybe jump into another executing TA. So we don't know when it's going to be dumped into other context in the middle. And the fourth thing, the standalone MM, it is a kind of bare metal, a bunch of application. So everything is static. The memory mapping is static. But the OPTI expect all of its TAs to be moved, relocatable anytime because of its ASLR, right? ASLR functionality. Yeah.
Yeah. So OPTI itself can. We don't have ASLR for OPTI core yet, but it's planned and it will be done quite soon. And once that's done, it means that certain virtual memory will be claimed for OPTI, and obviously SDMM cannot be using those virtual addresses. So that means that it's much easier to be able to load any binary at any suitable place, because what happens when OPTI is started, it finds out which virtual memory range is the optimal one to load user space code, depending on the layout of translation tables. This is sorry? Yeah. So this is fairly static. If we don't have ASLR, it will choose the same range each time, so it's possible to predict. But if you change configuration, you could suddenly get an offset by a couple of pages due to meltdown mitigations and stuff like that. So that's why we need a relocatable SDMM.
The reason we decided to do the problem we faced here is actually how do you talk from the non-secure world to the secure world, right? Now, due to using standalone MM and the decision we did to reuse whatever was on EDK2, what made sense for us is to use MM Communicate, which is arms management to talk from the non-secure world to the secure world. But as we went along, we figured out that if we want to support RPMB, then we're starting to facing issues because there's no driver on Linux or on U-boot doing management mode, and that offers whatever capabilities are offered by OPTI, like the RPC calls that we need to write the RPMB. The short term is that you can't use management mode at the moment to access RPMB devices. So since was that a requirement for us, we started getting into discussions of how should we wrap this? Should we change the U-boot driver, or should we just change OPTI, make sure we can load standalone MM, and then just manipulate the buffer from OPTI into standalone MM from within OPTI itself and make standalone MM work. And this is where your work comes in.
Yes, so the current design is to use you call into OPTI as usual when you communicate with other TAs. This time you communicate with a pseudo TA, which in its turn will pass on the payload buffer that you normally would supply in an MM Communicate SMC. So the internal protocol used by standalone MM is intact. It's just that the outer transport of basically the pointer, that's different. So instead of doing an SMC directly, the OPTI driver that we also have in U-boot will be used like open session and invoke command, etc.
Yeah, that's loud and clear. So I think MM is a very overloaded term over here because there is the MM communication protocol, which is a UEFI PI concept, and then ARM decided define the MM Communicate SMC to support that protocol, which is completely different. And what we are saying over here is that the UEFI PI bits, the MM communication protocol, that bit remains as it is. The underlying transport, the SMCs that we want to use, they're going to be OPTI SMCs. So that's the key difference.
The key difference is that the EDK implementation only deals with hardware that has a NOR flash in the secure world, right? Yeah. So
The synchronization one, yeah.
Yeah, the synchronization one is. So that's fine, because you don't need to go back to the non-secure world to write whatever data you have. And MM is fine. The MM communication is fine.
But there's one more thing. So the bit that we, Pipat said about the runtime model. So UEFI drivers, the standalone MM drivers, as far as I understand, they expect run to completion semantics. So it is worth, so it's about, Opti has a set of TAs and a runtime model that it exports to those TAs today. And that is like, yeah, they can sleep, they can get preempted, so on and so forth. Standalone MM is essentially a new type of application which expects a different runtime model. So it would be worth considering the fact that some of the things that apply to the normal TAs, they might not apply to the standalone MM secure partition, and how that would be reconciled is something to discuss possibly.
So the runtime environment will be customized for standalone MM.
Okay.
It will not be like a normal user TA.
Okay.
It will have another set of syscalls and so on, and it's not a problem to mask interrupts, for instance, while we are executing for a standalone MM, if that's a concern.
Yeah, because today we are focusing on the storage use case, but it could be any other driver, right, which might not react well to having been preempted and then resumed.
If people want to think about this differently, imagine that we can offer through Opti a way to execute secure payload, secure SPM payload. So that's what we're trying to offer via Opti, and you'll get the chance to run whatever you're running, plus whatever SPM applications you get.
That's the key thing, that for the developer who's writing the standalone MM secure partition, it shouldn't have to worry about the fact whether it is running under ARM trusted firmware directly, which is the current upstream implementation, versus running a trusted OS. It should be entirely transparent to it.
At least that's the goal.
Yep, we will see how it goes.
Yeah, that was. I guess that's everything I had to say. Yeah. You summarized it well at the end.
I don't know if anyone has any strong opinions on that. We don't. As LEDs, we see no reason of using grub at the moment. We boot the kernel directly into an UEFI stub. We know we won't have rollback that grub offers, but we haven't had any use cases we need this. So I don't know if there's any distro vendors in here that would like to comment that, but the current decision on LEDs is that every platform we're using just directly boots the kernel from UEFI. The next one is runtime services. We haven't decided yet if we're going to offer runtime services from UEFI. So one of the ideas that were presented during one of the steering committees is that the firmware presents a read-only copy of the variables to the kernel. And if you need to update a UEFI variable, the kernel prepares a capsule. You reboot the system, and then on the next reboot, the firmware checks the capsule, makes sure everything's fine, makes sure everything's signed correctly, verifies the variables it has to update, and performs the actual update. What you get out of it is that the UEFI runtime variables tend to be tricky to get them right, so you get the variable updates, and the obviously downtime is that the obvious problem on the solution is that you're going to require an upgrade, a reboot.
Where are the capsules stored? Is it in memory?
Yeah.
So what if you just cut the power and reboot, and you get the same old variable? So
we haven't sorted everything down. If you cut the power, the upgrade won't happen.
right.
We haven't sorted yet. Yeah. We haven't sorted yet if it's going to be on memory, because you have to, preserve the memory on soft reboots. You have to do stuff like this, but this is a problem anyway. So you either write the capsule on disk. Sorry, it's not in memory. We discussed this. You actually write the capsule on disk, because when the next time you boots up, there's code already in it that performs the capsule update, although capsules are not working yet. But the code for scanning the capsule update is there. So the idea is that you write the capsule on disk and then you just upgrade.
And this would kind of feed into the whole RPMB thing. So it's like if you were to visualize it, the disk has two parts. There's, say, the secure part of the disk and non-secure part of the disk. The capsule first goes into the non-secure part of the disk. You could do a reboot, come back again.
Exactly.
Now the secure world authenticates the write and then prepares possibly an encrypted blob, which goes back to which uses supplicant and goes back to the
RPMB, and you end up doing the update.
All right. Okay.
The key thing is that you have to verify the capsule anyway. So if someone messes up with it during the reboot or during the writing of it, the firmware will just reject the update.
Yeah.
The problem with this one is that we don't mind not supporting EFI runtime variables. We really don't see any. There's no use case for us that if we don't support them, something bad's going to happen. We're perfectly fine by just applying them on X reboot. And to be honest, how often do you upgrade the UEFI variables on your machine? The problem is that there's no capsule update on U-boot, so we're gonna go and have to implement that anyway. And what's
almost 1 year ago, there is a similar discussion about exporting the variable to the operating system, also importing the update of variable from operating system to firmware, right? And Peter from Red Hat proposed some draft for this specification, particularly the format of the capsule. Well, but after some discussion, the discussion totally stalled, right? So there is no new draft at this moment. So anyway, we have to define that.
Question: why don't we? I haven't seen the discussion with Peter. My question is, why don't we just use fit images for U-boot for the capsule? Parsing is there. Do a fit image with a DTB-like structure inside, and then you got the update working with practically zero code.
Anyway, we need some file format for the log, right? Transaction or variable update. Yeah, we need definition, right? That is my point.
Right. Any comments on that, or should we move to the next? Too many.
I think there is a use case for the UEFI runtime variables during a normal firmware update. The idea of the firmware itself needing to know the status of the firmware update, and so using a UEFI variable to know the status of whether on the next reboot it needs to install the new thing or not. So, but I think it's just only needs a read only. During the boot case, it only needs a read view of the variables, I think.
U-boot already executes a capsule if it's on a specific directory. So you don't have to update an EFI variable to instruct the firmware to execute a capsule update. You just pick up the file, place it on a directory, next reboot, U-boot executes it and deletes it, if I remember correctly. Okay. So you don't need the runtime variable to say, execute the capsule.
Yes, not for the U-boot. I'm thinking more of a secure world update of secure world code. But yes, I guess that could take the same approach maybe and store a file for that rather than But that secure world needs access to some file, whether that, and then we come back to that problem again.
So is there a format defined? So as far as updating, say, ARM trusted firmware sources using the capsule update mechanism, that's in the scope of what we're trying to solve over here. Okay. So
we haven't picked up the target at all yet. Let's be honest.
Okay.
We haven't done it.
Okay. because then, like, one of the problems, at least I've seen getting discussed quite a few times, is like, what's the format of the file system so that ARM trusted firmware can understand it and pick up the bits that it needs to, that it is interested in. So are we going to be doing that as well at some point of time?
Well, if it gets funded by the members, yes, because capsule updates is one of the things we'd like to work on, because obviously we need it for firmware upgrades, and we need it for variable updates as well if we go down what we've planned. So I'm pretty sure it's on the initiatives for this cycle. We hope it gets along and we can actually work on it to get the full solution running.
Yeah, I mean, as to whether the members do it or, you know, I think ARM's interested in this as well, but I think it'd be good this week to talk about what a good architecture for this looks like before anyone cracks off on with that work. Yeah.
Okay. All right. Your problem. Not mine.
When I implement timestamp-based revocation, well, I found that there is no timestamping tool on Linux. The only one tool I found the I think you said the OpenSSL command, right? As far as I know, OpenSSL can create timestamp, but they can't put that timestamp into image. Sorry.
Is this one working?
Sorry. So the problem is not generating the timestamps, it's generating the signatures that include the timestamps.
Yes.
The only tool I found is Microsoft SAN19-2. So I wonder people are happy with this command using Windows for Linux system. That is my question.
Does EDK do timestamp checking? Remember? Too early.
Yeah. I wonder if people really want to use a timestamp-based replication.
Since no one knows the answer, you keep using the Microsoft tool.
Yes. So next topic is testing. I also feel some difficulty to understand UEFI and secure boot specification. It was very difficult for me to understand the specification, particularly timestamp-based revocation. There is only one small paragraph. It's a very ununderstandable. Yeah, so my approach was to look into the corresponding EDK2 code and understand that and port that functionality to Ubuntu. So my concern here is I'm not quite 100% sure my implementation comply with the UEFI specification. So I need more extensive test cases. I mean, I made quite simple test cases in Ubuntu right at this moment, but I think we need more extensive test cases. UEFI SCT is not a solution because it's not. It doesn't contain any test cases for image authentication. It's I think, right? No.
If you say so, true. That clearly needs to be fixed.
Yeah. So another concern is, I want to implement. My implementation work in the exact same way as EDK2 does in terms of the UEFI secure boot. So I want to run the same test cases for EDK2 and the Ubuntu to confirm that. Yeah, that is another challenge. So.
So, I mean, the first step would be raise a ticket on the Tiano Core Bugzilla to make sure that it's being tracked. And, whether you do it or someone else does it, it sounds like something that needs to get fixed.
Yeah. At least, instead of going again of branching off testing, at least let's try to make it common.
If we branch the testing, then we've missed the entire point.
Exactly.
Yeah, thank you.
This is all the slides we had, right? For this. Okay, we have some backup slides if you want, but I think they get way more technical. But anyone has any questions on the whole discussion we had, any suggestions? Something that you wanted to hear and you didn't?
What are the next steps?
Okay, the next steps is that we're going to try and upstream Acacia Sans code because it's splitting the UEFI variables and adding the EFI payload authentication is not minor. Each one of them is a pretty big task on its own. So it's like two patch series of 15 patches each. Yeah, I think it's 15 patches each, and pretty much no one is willing to review them. So he has done all the testing he had to. We'll try to review it internally as well and test it on the boards we have, make sure that everything is working. The good thing on this one is that we're already in touch with Heinrich, which is the EFI subsystem maintainer for U-Boot, and he's fine with the whole idea. I mean, we explained standalone MM, we explained what we want to do, why we want to do it. And he said architecturally he's fine with the whole approach. So we can go ahead and start proposing patches. So we're going to have them merged sometime in the next cycle, and we're going to do our best to get that happen. If anyone wants to test those, first of all, there's the mailing list, and second, there's a tree on Takahiro's Git, linear Git tree, which is the whole U-Boot with the patches. So the next step is we're going to try and run standalone MM within next week at some point, which is running it. It's a P binary, it's self-relocatable, so in theory we won't have any issues. Or at least that's what we hope. So once standalone MM runs, what we have to do is we have to change the U-Boot implementation to get variable, set variable, at least the basics working. Sugo's work from ARM has done this, but he added the commands on U-Boot with the initial design we had. So it implements MM communicate in U-Boot, adds MM communicate on TFA, on optd. He routes the calls up to opti. So what we have to do is do the get and set variable with the opti implementation, which I think you're going to do it, right? And once we have standalone MM running, then the other part is changing the APIs, ripping out the storage because we won't use the memory mappings. We've already removed the storage. So remove the storage, change the storage API with opti, and then start testing.
So we can expect some kind of, say, RFC patches on how standalone MM partition itself is going to be integrated into opti.
That's for Jens to answer.
Yeah, we can expect that will be an RFC.
So I guess the secure partition is just going to be built into the opti image, just like a static TA.
Yeah, it will be built into opti, and to interface with it, you will open a session to a WTA.
Right. Okay.
So there will be no need for changes in trusted firmware, for instance.
Yeah.
Since we can use a normal opti dispatcher.
Yeah. Okay.
That was the whole point of not using MM.
Yeah, like we'd be interested in seeing how the packaging is being done, right? Because then this would kind of extrapolate into what we do with SPCI eventually. So yeah, there's an intersection over there. So yeah. Thanks.
Okay.
So the standalone MM part, when integrated with Opti, this will work with UEFI also, right? I mean, I'm assuming when you're talking about Opti and a trusted application which has a standalone MM and other trusted applications working, you're talking about U-Boot with EFI secure boot. So this, if instead of U-Boot I have a UEFI, so that would also be working. This would also be tested.
Sorry, I didn't get the...
So we're talking all about over here is that with U-Boot, you have an EFI boot working and a standalone MM part. So on my platform, if I have a UEFI secure boot and I have a requirement where along with UEFI secure boot, I can have an Opti working. So this kind of translates to that also, like on an ARM V8 platform. So this also would be tested?
Yeah. All right, at least I talked to Ard. I haven't talked to you further. But the discussion we had with Ard was that we want to submit the standalone MM changes we have in the EDK to the code base. Definition, something like that. So we want common code. And the idea is that this is going to run on ARM v7s and ARM v8s as well. So you can choose, when you build EDK, you'll ideally be if you build EDK and there's an Opti implementation in the board you're running as well, you'll be able to use the same code regardless of U-boot or EDK. The whole functionality is what the firmware provides and who runs it on the secure world. It's irrelevant of the other two.
Yeah. You said the same code. Do you mean the same binary or from
the same source code?
So I guess
no one cares about the binary.
It boils down to that either the communication driver in the normal world, either it would be able to rely on a trusted OS provided transport, or it would be able to rely on the communicate SMC. So, and that the choice is entirely up to the platform.
Exactly.
Right. Okay. Yeah.
At least that's the goal. I mean, that's what we're planning for anyway, because we have, it doesn't, speaking from the perspective of LEDs, it doesn't make sense to support SPM for ARMv8 and whatever we do for ARMv7 and have to debug double the code, figure out have double the test. We don't really, this doesn't make sense for us at all. So we have a common use case. And to be honest, no one really cares how you store it, because the goal is store my variable securely. No one cares how you do it eventually. Anyone else?
Just coming back to this, the subclink case where you have to write into an RPMB, that you know, at runtime, that's fine. You have a Linux driver which does that. Are you saying that also works at boot time in U-boot? So U-boot has the same kind of Linux check? Yeah, okay. Because one of the use cases we're also looking at is trying to get the secure world, very early bootloader, BL2, accessing secure storage, and obviously Opti is not even installed at that point, and so we're having to look at, you know, do we install Opti early and then go back to BL2, or do we actually have some knowledge of the file format to directly access?
The problem we're going to have at some point is that it works on Opti, it works on the bootloader, and no one cares about interrupts on the bootloader. You can disable them for 10 minutes and no one will even care. The problem is that if you want to support UEFI runtime variables and have this working on a running operating system, you're going to have Linux crying out loud saying, whereas my interrupts are disabled for like a second.
I'm only talking the boot time case, not using in runtime secure firmware. I'm not talking about that. Yeah.
So for that use case, Dan, would it be possible that ARM trusted firmware assumes, say, kind of ownership of a particular section of storage, and it knows that, well, Opti will come later and hands over to Opti instead of having a dependency on Opti? It can just do things independently and not worry about Opti.
But there's only one RPMB block, isn't there? I mean, you can't partition that up, can you? Further, can you?
I don't know. I personally don't know. I know you can have a partition. I don't know how you can access it.
But even if you're not able to partition, it's like there would only be a single user of it at any point of time. So after boot, it's ATF, which is the user of it.
But it needs to be persistent over.
Yes.
So you can't overwrite it.
The problem with the RPMB is clearly, if you try to work on QEMU, you clearly have the problem, because in order to have RPMB access, you need either Linux or the bootloader to come up before you can access anything. I'm pretty sure it's the same problem on a different perspective.
But in this case, like ATF will carry a RPMB driver then, right, in BL2?
How many drivers? That's the next. That's the problem. If you start talking about adding drivers in different parts of the operating or different operating systems, we had the discussion about having a driver on Opti, and we started thinking concurrent accesses. How many drivers? No, we're not doing.
If I understand the use case over here, the normal world is completely out of the picture in this at this stage, right? So there's something from the secure world needs to write to the RPMB. So you
before Opti is up, so you need a driver on TFA, right?
Yeah.
I don't think we need to have a write driver. We only need to be able to read a variables. Right. So you could look at some simplified driver, which, if either by directly understanding whatever the file format that EDK2 and Opti uses in order to is one.
Since it's an RPMB and you rely to Opti for the key management, you're going to have the key management as well in TFA. So you're going to have everything in TFA: key management, read the driver.
I'm not
All right.
I don't know the solution yet. Another solution could be, as I say, try to install Opti earlier and all the bits in.
I mean, having something that pulls Opti from the TFA and make sure that you have access. trying to pull opti from TFA, from TFA, and trying to make sure that it's up before actually accessing the RPMB sounds easier, at least.
I don't think that's what that was.
Yes. One problem with having TFA reading RPMB directly is that we need to have a well-defined format. If we rely on opti, then it's enough that opti has an interface that can be used.
Is this a valid use case? Why don't you have TFA anyway, probe for opti?
Well, it's like, so Dan, you can correct me over here, but this is like BL2, which is after a cold reset, that wants to write to the RPMB, and that having a dependency on opti, I'm wondering how would that...
It doesn't want to write, it just wants to read.
Okay, but even for the read, like opti comes...
The read before you're able, the read is a dependency to load opti.
Yeah.
Okay.
So
That's a problem.
that seems like a problem, right? So I think this is like a common theme that we have secure, we have storage, part of it secure, non-secure, and now further within the secure world, you can have multiple consumers of the storage. So maybe coming up with some kind of guidelines on that front, that on ARM platforms, this is how this should be, these multiple consumers.
Another solution might be, we get some code, some opti code, which provides that interface into whatever the storage format is, and we just import that code into the TFA in order to insulate itself from the whatever storage format there is.
We just have to make absolutely clear that having two drivers accessing the same medium is not a good idea.
Yeah, like in this case, it wouldn't be at the same time.
Yeah, at least that's clear. Yeah,
that's the thing. So yeah, that would work if we have an opti library / module running in BL2.
More work for opti.
Yeah, you'll just have a dispatcher in BL3 and a dispatcher in BL2 as well. So.
Are we out of time? Yes. All right. Thank you. If you have any other questions, I'll be around. Either me, Jens, but anyone can answer most of them. So. All right. Thank you.